Hello, mathematicians. Okay, we are actually starting with trigonometry. I'll come back to this, but in order to understand trigonometry, which is the study of relationships between angles and sides of triangles, we kind of have to have some vocabulary first. So I do want you to have your notebook out. I do want you to draw two nice big triangles. Notice that I have them labeled here. If you need to pause the video to get them drawn, go ahead and do that. Once you have drawn them, go ahead and come back. Okay, now I am going to show you how our three vocabulary words that you're going to use for trigonometry appear up here in the triangles. So our first thing that we need to know about our triangles is, as we label them, notice that C is our right angle, and that is always going to be C. And then notice that because C is here is our right angle, that means that the side opposite of it, notice I can even draw the little arrow, is the little c. And so we call this C. And we notate it by a lowercase c. Notice that we also do the same thing with our angle A. Notice that angle A is up here at the top. If I actually were to draw an arrow to the opposite, notice that I have a lowercase a. So this is going to be side A. Now that is the leg of our right triangle. And then finally, you'll notice that we have angle B over here. I will do the same thing. I will draw an arrow across to the opposite side. They are always pointing to the side that they are paired with. So if this is angle B, that means this side is side B, and we note that with a lowercase b. So have this drawn in your notes. If you want to, grab different colored pencils just to kind of help you understand how that triangle is put together. Now, as we go and take a look at our vocabulary words, I want to make sure you write down these definitions, and then we'll talk about them when we go into our next triangle. Notice that adjacent, that means next to. It'll actually be touching. Our hypotenuse is the longest side of the triangle. And it is always going to be opposite the right angle. Opposite of the right angle. And if you need to, pause the video and catch up. And then finally, opposite means across from. And as we, so notice that here our opposite side is opposite of the angle. So as we work on this, I'm going to now go ahead and use this triangle, and we're going to work this triangle as if we are using angle B. So we're going to make angle B the star of our problem here. We want to know everything about angle B. If this is angle B, then I know that right here, this is going to be the opposite side, because it is opposite of angle B. What that means is, then A is going to be my adjacent, because it is touching. It is next to angle B, and it is touching angle B. And then finally, C is our hypotenuse. And it's our hypotenuse because it is across from the right angle, and it's the longest side of our triangle. Now, this actually switches if we were to look at angle A. So that's why we have to be really careful. I want you to do highlighting so that you really can understand this as we work on these triangles. So let's go ahead. I will keep referring back to this, but let's go ahead and jump into our worksheet. I will kind of talk you through this, and we'll go from there. Okay, so what we're going to do is we are going to look at each acute angle of a right triangle has the following trigonometric, I can't even say it, guys, ratios, trigonometric. These are ratios that we are going to use to solve problems. In other words, some problems we're going to know some of the measurements, and we're going to be looking for other measurements. People actually use this all the time, especially when we're looking at trees outside, when we're looking at telephone poles, anything that has a tall piece, and we are standing here on the ground. So we actually used trig, and we use Pythagorean theorem quite a bit. Okay, so let's go ahead and look at our first one. Sine. Sine is when we are looking at the ratio of the opposite and the hypotenuse. So if I were to take a look at this one, and I wanted to find my sine A, so I'm going to use my A. So just like over here, I used B. This time I'm using A. Now sine is known as opposite over the hypotenuse. And I kind of abbreviated opposite over hypotenuse. We might actually just do this too. Remember, adjacent is an A, hypotenuse is an H, and opposite is an O. So we talk about being lazy mathematicians. I don't want to write the whole word, so I'm just going to use A, H, and O. So if you need to, refer back to your notes. Now, in sine A, sine means I have to look at my opposite plus my hypotenuse, or over my hypotenuse. So I'm going to start at A, and I'm going to look for the opposite. The opposite is little a. And I have to use the hypotenuse. Since I'm here, my hypotenuse is C. Okay, I kind of didn't fit into the line. Now, what if I were actually to do sine B? What if I were using my angle B? Sine is still opposite of over hypotenuse. So if I'm looking from this angle, my opposite is B, and then my hypotenuse is still C. So that is how we find sine, and we call it S-O-H, sorry. So, S-O-H. And I'm going to teach you all the acronyms, okay? So is opposite over hypotenuse, and that is going to be sine. Our next one is cosine. Cosine is a ratio, but this time we're going to use the adjacent leg and the hypotenuse. So down here, cosine is going to be adjacent over the hypotenuse. Adjacent means next to. So if I have cosine A, okay, let's start up here, A. Since I'm at A, I want to find the adjacent. Remember, it's the one that's touching. B is what is touching. It's next to A. So I'm going to put B over my hypotenuse. Well, hypotenuse is still C. Hypotenuse is always C. Now, let's pretend I'm using B, cosine B. Again, I'm going to use the adjacent. What is right next to B? Little a. Over my hypotenuse, which is C. And then tangent. Tangent's a fun one. Tangent looks at the ratio between the opposite and the adjacent. So we call it opposite over adjacent. And so opposite over adjacent. If I'm doing tangent A, here I am at A. I want the opposite, so I'm going to look across. There's the A. And then what's the adjacent? What's it touching? It's touching B. So it's A over B. Now, what if I look from the other view? Now I'm going to pretend I'm standing here and I'm looking this way. I need my opposite. My opposite is lowercase b over adjacent, the one that it's touching. Well, it's touching the little a. So how I remember all of these is so, and then I say ka, and then I use toa. SOHCAHTOA. Everybody remembers this. I remember this since I was in high school. You just always remind yourself, SOHCAHTOA. SOHCAHTOA tells us the order. Sine uses opposite over hypotenuse. Cosine uses adjacent over hypotenuse. Tangent is opposite over adjacent. I will have this up in the classroom and you have it here in your notes. Okay, so let's go ahead and try one of our problems here and write our ratios as fractions. I will get started with one and then I know this is a long video. Bear with me. We'll do a few. Okay, sine A. If this is sine A, I'm going to circle A. That means I'm standing here and I'm looking at my other numbers. Now, since it's sine, I want to do opposite over hypotenuse. What's opposite of A? Ah, it's a 5. What is my hypotenuse? Remember, my hypotenuse is the longest, right? So that's 13. And that's my ratio, 5 over 13. Now, what about cosine A? Okay, no, I'm still at A. Well, I'm looking from the angle of A. And A, cosine A, adjacent over hypotenuse. So which one's touching A? Remember, I want the leg. The leg is 12. And then over the hypotenuse, which is 13. And then finally, tangent. Tangent means I am going to start at A, and I'm looking at A. But now I want the opposite over the adjacent. So my opposite is 5. And my adjacent, my touching one, is 12. So remember, always take your angle, and then if you need to, you notice that I'm turning my paper so I can see my perspective. So go ahead and practice a few, check in with me, make sure you're writing them correctly, and I'll make another video for the next part. You got this.